The next concept we need to talk about is a reference angle. All right, so a reference angle, we're going to let theta be an angle in standard position, starting at the positive x-axis and rotating to my terminal side. Its reference angle is going to be the acute angle theta prime. That little line means theta prime, formed by the terminal side and the horizontal axis. So what we're going to have in this first picture, I have my angle theta. This angle theta rotates me into the second quadrant. So when I draw a triangle, I need a right triangle. That theta, I'm not getting a right triangle. So I'm going to use this angle theta prime, which is going to be the acute angle that forms with the x-axis. That's going to be my theta prime. Now, the reason we want this is because once I get theta prime, I can draw a right triangle using that small angle. All right, your x-axis, I've said it several times in class, always, always, always forms with the positive or with the x-axis. Your angle, your triangle, always is going to be drawn to the x-axis. So over here on the second picture, I have this larger angle that rotates into the third quadrant. That's my theta. My theta prime is going to be this angle that's formed the terminal side in the x-axis. So it doesn't have to be a positive x-axis, it has to be the x-axis. That is going to be my theta prime, my acute, my less than 90-degree angle that allows me to draw a triangle to the x-axis. Those are our reference angles. How that's going to help us is I'm going to ask you to find me the reference angle for a particular angle, like theta equals 300 degrees. All right. Theta equals 300 degrees. I'm going to ask you to find me the angle that the terminal side of this 300-degree angle forms with the x-axis. So what I'm going to do is I'm going to draw a 300-degree angle. A 300-degree angle is going to rotate me all the way into the fourth quadrant. It goes past 270 to 300. So this is my theta. My reference angle is going to be theta prime, which is going to be that angle. So we need to realize that if this big angle is 300 degrees, that my reference angle, this angle here, is going to be 60 degrees. And I'm not going to make it negative because I want to be able to draw a triangle and use that theta prime. And if it's negative, we don't do negatives in triangles. So it's going to be an angle between 0 and 90 degrees that's formed with the x-axis. So my reference angle is going to be 60 degrees. It's always the small angle, less than 90 degrees, that forms with the x-axis. So we'll do negative 225. Right, negative 225, I'm going to rotate down. So this is down 180. And then I need to go down another 45 degrees. That puts me here. It helps to draw the picture so you can understand where you are. So this is my theta, which is negative 225 degrees. Now, this angle theta prime is my reference angle. So if I rotated negative 225, that means I went negative 180 and an additional 45. So my reference angle, my theta prime, is a 45-degree angle because it was 45 degrees past 180. My 60-degree angle is 60 degrees short of 360. All right, so all of these, we're going to make it in relation for degrees in terms of 360s and 180s, how much we're short or how much we're past those two angles. All right, so you draw the picture, you label it, you figure out what the other piece is, which is your reference angle. All right, 8 pi over 9. 8 pi over 9 is almost 1 pi. So So 8 pi over 9, I'm going to draw to here. That's my 8 pi over 9. So that makes my reference angle this angle. So if I'm 8 pi over 9, I didn't rotate all the way to 1 pi. I'm going to be, with this angle here is going to be 1 pi over 9 short of pi. So pi over 9 is going to be my reference angle. So what we're doing is all in relation to a half a rotation or a full rotation. So it's all in relation to pi and 2 pi, in relation to 180 and 360. That's how we're going to figure them out. All right, the last one. This is in radians. Let me put radians just so we realize it. My theta is 4.6 radians. I want you to find me the reference angle. So somehow we have to be able to graph the angle 4.6 radians. Pause it if you want to give it a shot. All right, so we have to figure out where this angle is. And I will tell you that this angle, let me do a different color, is going to be almost to the bottom. So 4.6 radians, I'm going to tell you, is almost to the bottom. The reason I know this in terms of radians is I have this integer, or not integer, this decimal. We are used to having a pi in it. So what I'm going to do is find out 4.6 is how many pi's. Because I want to be able to rotate some form of pi. So what I'm going to do is I'm going to divide 4.6 by pi, which tells me that 4.6 is approximately 1.464 pi's. 1.464 something pi's. Because I took this 4.6 radians and I wrote it in terms of pi by dividing my number by pi. All right, so now I'm going to rotate almost 1.5 pi's. That puts me down here in the third quadrant. This is my theta. So now, this angle here is my reference angle. So I want to know what this theta prime is. If this whole angle is 1.464 pi's, I'm going to say my reference angle is going to be 0.464 pi, or $1.458. I got rid of the pi. I multiplied that times pi and got 1.458. The reason is, if this whole angle is 1.46 pi, I want to ignore 1 pi. So I can say, take my 4.6 and take out that pi that I don't want and get 1.458. Or I can take my 1.464 pi and subtract 1 pi from it, which gives me 0.464. It's all in relation to pi's and 2 pi's. You have to figure out if you're short or past if you want to add or subtract them. So for this one, 4.46 or 4.6 radians, I converted it to pi's by dividing by pi and realized I ended up in the third quadrant, which means I want to ignore the whole pi and only worry about the leftovers. So I'm going to take that 4.6 and take out a pi, Or I'm going to take my 1.464 and take out 1 pi. A little confusing, a little tougher to think about, but convert it to pi's. Divide it by pi so you know where you're going to draw your angle and go from there. All right, the last part. We're going to continue what we did last class. Last class we talked about first quadrant only. Now we're going to talk about all 4 quadrants. All right, so we're going to find 2 solutions. I want degrees and radians. I want my degrees between 0 and 360, where 0 is a good answer. So if it rotates all the way to the right side, you tell me 0, not 360. And between 0 and 2 pi radians, where 0 is a good answer, 2 pi isn't. So if you rotate all the way around again, tell me 0, not 2 pi. All right, thought process. Cosine of theta equals negative square root 2 over 2. The first thing I'm going to worry about is this negative sign. We talked about it a little bit in class. Cosine is negative, which means my x's are negative. When my cosine of theta is a negative answer, that means my x values are negative, which means I'm going to end up in the second or the third quadrant. End up in the second or third quadrant because my cosine is negative. Those are negative movements. My cosine is my x value, so I'm going to have a negative square root 2 over 2. Because of my unit circle and all the good ones that I know, my reference angle for any square root of 2 over 2 is pi over 4. That's my reference angle. Now, I'm going to need the pi over 4 in the second and the pi over 4 in the third. That's just knowing what they are. That pi over 4 in the second is 3 pi over 4, and the pi over 4 in the third is 5 pi over 4. And those are going to be my 2 answers. That's knowing what the good angles are from your unit circle. I don't want you to look at the unit circle to figure out the answers. I want you to go through the process. Cosine of theta being negative is in the second and the third. My x value has to be square root of 2 over 2. That tells me it's a pi over 4. My pi over 4 in the second is 3 pi over 4. My pi over 4 in the third is 5 pi over 4. So we're going to add plus and minus signs that put them in other places other than the first. So we have to find them all. All right. Number 9, cotangent of theta is negative 1. All right, if I don't like that, I'm going to say that the tangent of theta is its reciprocal, which is also negative 1. Both are going to work out the same. All right, now when is my cotangent, or where is my cotangent or my tangent going to be negative? All right. Cotangent and tangent are y over x and x over y. So what I need is I have to put those two over each other and get a negative answer. So I'm going to say, like we said in class, I'm in the second or the fourth. Because this is a minus plus, which is negative, and this is a plus minus, which is negative. So I'm in the second or the fourth. All right, so I need my x over my y, or I'm sorry, I put on the wrong one. My y over x, or my x over y, to give me an answer of negative 1, or 1. So if I put a number over some number, I have to simplify to give me 1, which tells me that those two numbers are the same. And from my unit circle, the only ordered pairs that are the same. So when I put them over themselves, I get 1 is square root of 2 over 2, square root of 2 over 2, which are going to be my pi over 4s. So my process is my tangent, cotangent are negative. And the second and the fourth, because the signs are different. To put my x over my y, or my y over x, and get an answer of 1, my ordered pair has to be the same. And the only ordered pair that's the same is square root of 2 over 2, square root of 2 over 2, which is my pi over 4. All right, if we do these without a calculator, which we should be doing, they have to be angles from the unit circle. All right, so my pi over 4, here in the second quadrant, we already said was 3 pi over 4. This one, and my other one is going to be the one down here in the fourth quadrant, which is 7 pi over 4. Your pi over 4s go 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. 1, 3, 5, 7 pi over 4s, first, second, third, and fourth quadrant. All right, last one. Sine of theta is negative 1/2. Sine of theta is negative 1/2. No, you shouldn't need the unit circle for 6. We shouldn't need the unit circle for 6 through 9. We should be able to go through a process. All right? No unit circle. You can use the unit circle if it's in your head. Okay, and that's what you should be using. Okay, there's a process to go through. We shouldn't have to look at it, but you should have a general idea of what it is in your head to be able to use for 6 through 9. All right, tangent of theta is negative 1/2. Sine of theta is negative 1/2. I know my sine are my y values. My y values are negative on the bottom. All right. So my ordered pair has to be something comma 1/2. All right. My ordered pair is something comma 1/2. I know my x value. If my y value is 1/2, my x value is square root of 3 over 2, because that's a good one on the unit circle. And when my x value is square root of 3 over 2, 3 times 2 tells me this is my pi over 6. All right, so my answer is going to be some form of the reference angle, pi over 6. And I'm going to pick the pi over 6 that's in the third and the fourth quadrant. Sine's negative on the bottom. Sine is y, so my y value is 1/2, which makes my x value square root of 3 over 2. Square root of 3 over 2 and your x value is a pi over 6. So I'm going to say these are my 2 pi over 6s. My pi over 6 in the third quadrant is 7 pi over 6. My pi over 6 in the fourth quadrant is 11 pi over 6. Pi over 6's go 1, 5, 7, 11. 1, 5, 7, 11. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, so the idea for these, and a lot of today's lesson, is understanding what quadrant you're in based on if the sine of an angle is positive or negative. Tangent of an angle gives you a positive or negative answers. You got to be able to figure out where you are. That's a lot of today's lessons. And then being able to pick angles, if I know a reference angle is pi over 6, know the pi over 6 in the third and fourth quadrants are 7 and 11 pi over 6. Right, if you have any questions, send me a message. If not, have this done by the time you come to class on Tuesday or Wednesday, or Tuesday, whatever day you see me next. All right, have a good one.